Okay, solving simultaneous equations. There's two methods we can use. We can use the substitution method or we can use the elimination method. The way this is set up, probably elimination method is the better one, but I'm going to show you substitution. I'll show you both ways. When we look at the substitution method, we're looking at the variables and we're looking for one that's easy to make the subject of the equation. So make it so it's by itself on one side of the equation. So if we have a look at both sets of equations, the easiest one to make by itself is that y there. Okay, it's really easy to do. You just got to subtract the 2x over. So we're going to say from equation 1, we're going to have y equals, now if we minus the 2x over, we're going to have 15 minus 2x. Now I'm going to call that equation 3. Okay, and what we're going to do is sub y from 3 into equation 2. Okay, it came from 1, so we've got to sub it into 2. And so to do that, we're going to rewrite equation 2. So 5x plus 2. Now that y there in the second equation is equal to this y in the third. So because that's equal to 15 minus 2x, it means that y there is also equal to 15 minus 2x. And we're timesing, so with brackets, we're going to put in that expression. We're going to finish off writing the equation. So that's still 5x plus 2y, but y is 15 minus 2x, equals 39. So we've just rewritten equation 2. And now we've got an equation that has one variable in it, just the x, that we can solve and work out the x variable. So let's keep the 5x as is, expand these brackets, minus 4x equals 39. Okay, collect the like terms. 5x minus 4x is just x, and we're adding 30, so we're going to have that equal to 39. Now subtract 30 from both sides, we're going to have end up having x equal to 9. Now that's just solving for the x. Now we've got to actually solve for the y as well. So we can substitute that x equal to 9 back into any of these 1, 2, or 3 equations. And probably the easiest one to do is the third one. So we're going to sub x equal to 9 into equation 3. So it's simply y equals 15 minus 2 lots of 9. Now 15 minus 2 lots of 9 is 18. So 15 minus 18 is negative 3. Therefore, solutions are x, or the solution is x equal to 9, y equal to negative 3. Now, if I was doing this in the test, I would actually go and double check that they do work out. I'd be subbing x equal to 9 and y equal to negative 3 in there and making sure I get 15, which, 2 times 9 is 18, 18 minus 3, or plus minus 3, is 15, and then 5 times by 9 up the top here is 45, plus 2 lots of negative 3, which is negative 6, that equals 39 too. So it does work in both of those equations with that variable. So that was the substitution method. Whoa, holy dolly, what happened there? That's the substitution method. Now I'll show you in a different colour the elimination method, which, yeah, like I said, the way this is set up, it's probably the easier way of doing it. So when we've got it where, yeah, you've got both variables on one side, it is easy to eliminate one of the variables. So best way to do that is try and match it up so that we've got the same coefficient, the same number in front of one of the letters. Now the easiest way to do that is to take equation 2, and if we multiply everything in that equation by 2, it's got the same y coefficient, okay? And we'll see why that is good to do in a second. So we're going to go 2 multiplied by equation 1. So that's going to give us 4x plus 2y plus 30. All I've done there is just multiply each of those terms by 2. Now what that allows us to do then is if we now go equation 2, take away equation 3 is what I'm going to call this one. So we're going equation 2 minus equation 3. That's where we're going to go everything in this one minus everything in this one. So 5x minus 4x, well, that's just x. If we've got 2y from equation 2 minus 2y from equation 3, that's 0. So that's the whole point of doing that, getting that same coefficient, is so that we can eliminate. We've eliminated the y variable, okay? But now we've got to do the same now for our constant terms. We've got to go from equation 2 first. 39 minus 30 on that side is 9. So we've got x equal to 9 pretty quickly and easily. And now we've just got to do the same thing. We've got our value for x like we had over here. Now we've just got to substitute into either of the equations. I'm going to go to equation 1, sub x equals 9 into equation 1, and we've just got to solve. So we go 2 lots of x, so remember equation 1 is this one up here, 2 lots of x, so 2 lots of 9, plus y equals 15. 2 lots of 9 is 18, plus y is equal to 15. Subtract the 18 from both sides, y is equal to negative 3. Therefore, solutions are x equal to 9, y equal to negative 3. Same as what we got using the substitution method. Okay. Now, I don't know whether the question will specify a particular method, but you can see how either of those methods could be used to solve these.